I think that what you could have asked, what hype and at what time? So if you looked back 20 years ago when we were in diapers, just in terms of taking a concept into something that you could hold in your hand, it was so disruptive that inevitably everybody hyped it because it was a big idea. The fact that you could, for the first time, go from an idea in your head to something that you could hold in your hand. And we all immediately began to imagine all the possibilities, how it's going to create better products, how we could prototype in a fraction of the time, how instead of waiting many months to iterate on an idea, we could do it, within a few days. And so, and how it could change the way that we design language, how we treat, how we teach, how we teach everybody digital literacy, what's the impact on healthcare and well-being and humanity and the planet. So there was naturally a lot of hype and a lot of excitement. We are at a stage in which we nailed the prototyping. It's mature, it's democratized to a large extent, it's capable, it's repeatable, and you kind of give yourself a big attaboy, a check mark, and we move on. Now, the next big opportunity, and we've nailed it, by the way, in certain medical devices, certainly in dental applications at convincing scale, aligners and so on. Those are mature and they're benefiting many companies and their patients and clients, right? We're now aspiring to take this and build on it to manufacturing. That's a steeper mountain to climb. It's much harder. It requires a different motion, different mindset. And we definitely should not hype it because it's going to be hard. And it will require the entire industry to rethink our business model and migrate from selling boxes and materials and 100 different workflows into truly a collaborative, integrated solution provider kind of a mindset. And that's a whole different muscle, and it requires different kind of leadership. So it's a really good question. When I speak about language, I mean primarily the kind of coded software workflows. So if today you want to convert any kind of a CAD file into an STL file and begin to prep it for a specific printer, we're not all working on the same software. So there are dozens, each OEM by and large, each printer supplier created their own language, created their own workflow. Those are not interoperable. You can't easily go from one to the other. As a result of it, the consequence is that if you have a user, and most users now own multiple technologies, by default, we force them to learn all these workflows, which I kind of loosely call languages. By default, we make it more difficult for them if the system is closed versus open because it limits their material choices. And by default, they might not have the same ubiquitous experience that we want them to have, depending on which printer they use, what material sets. So we're making it harder for ourselves because we come back from a business model of traditional razors and blades, just like HP did back in the day with their 2D printers. And it was good a decade ago, but it doesn't scale if you really want to democratize access, if you want to induct millions of newcomers into the space, and if you want to take it into the manufacturing floor. It just doesn't scale with all the self-inflicted constraints that we impose. And in how we speak about mechanical performance of materials. in how we speak about the sustainability aspects, in how we speak about print speeds and throughputs and yields. And I can go on and on and on. If we really want users to be able to compare, contrast, and select the best tool for their problem that they're trying to solve, we need to be solution providers. And as solution providers, we need to take a page out of the injection molding providers and CNC providers. They all speak in a common language. You can see it as a problem solver, and you can compare all their data, and it will be comparable. They define curves the same way. They measure the same way. When you speak about tolerances, you know what you're talking about. When you select the material, you can, it's the same material regardless if you use it on one machine or another, and we don't have that today in additive. Well, you can see in areas where somebody's business model absolutely depended on it. Like see Invisalign 20 years ago. The only way for them to transform the orthodontic space from wire and bracket to aligners was through 3D printing. They had to double down and figure out how to do this, right? So they scaled. It's a giant company today, and they created a whole movement around digital aligners. If you look at the private space industry, the only way for them to be able to do what they are doing was taking the additive route to unlock the full potential of space privatization. And believe me, I was there. I was a member of the X Prize, which launched the first competition, the Ansari X Prize, to kind of create the privatization of space. But it was powered, and it's at the heart of it, what enables it is 3D printing. So in those cases, when your business model absolutely depends on it, entrepreneurs and innovators will go to any length to solve it. But to unlock the same benefit for everyday automotive applications, for additional aerospace applications that heavily, and by the way, automotive and aerospace both depend on lightweighting. And lightweighting, in many instances, taking it to the next level, is at the heart of what 3D printing can do. But since their business model doesn't depend on it, because they have a solution today, and since they have live product lines and their sales depends on it, they will be slow to adopt, because by nature, traditional manufacturing is conservative, right? Above all, do no harm. Don't shut the production line. Don't interfere with progress. So it's incumbent upon us to guide and speak to them in a way that they can hear and understand, and to enable them to adapt additive tools with confidence, and which means reduce the friction, reduce the risk, speak in a common language, offer the best tools even when you're not the provider of the best tools, and help make an integration happen. Well, I have come to the conclusion that we're in this small place today with all of the people that we know because we kind of defined ourselves as an industry, and we're drinking our own Kool-Aid. We're not an industry. We are a collection of tools and capabilities that in success can be part of a manufacturing ecosystem. But we're just a set of tools and capabilities. And so for me, I like to think about the mission as how do you make the digital manufacturing flow hum on all cylinders, and what does that look like? What is that future state? And within that, I see more than just 3D printers and and related additive manufacturing tools, I also see a lot of other digital tools like sophisticated CNC machining and next generation robotics and some kind of vision and scanning systems, and of course injection molding systems, especially electric injection molding systems and so on. And all of that has to be weaved into a digital thread that also ties into the manufacturer MES system and ERP system, which means we need open APIs. And if you think like that, then you would think of a very different conference here, right? This is not going to be just TCT RAPID for additive. It's going to be TCT RAPID for digital manufacturing. And in success, you'll have here all the CNC guys and all the tooling guys and all the molding guys. And it makes the conversation much richer, and it begins to break down the self-inflicted barriers of us as a tiny little industry. And one of my colleagues pointed out that even on the panel today, it would have been amazing to have maybe a few of those guys. I mean, we kind of had it with Niels, who is from DMG Mori and does both, but it would have been amazing to have kind of the outside-in look of the very target that we're going after. But additive has been around since the mid-'80s, and it's going to continue to evolve into manufacturing in ways that manufacturing can adapt it. I mean, look, every technology, if you look back at robotics, if you look back at CNC machining, if you look back at AI, if you look back at 3D printing, it takes several decades to reach sufficient maturity before you can, go to the next step function. It's kind of where we are. And what we need to figure out as an industry is, A, how to be sustainable and profitable. B, how to make sure that our appetite for innovation and R&D is matched by what customers really need and want, because today a lot of our innovations are solutions looking for a market instead of problems looking for solutions. And so as an industry, we have spent billions and billions and billions of dollars on R&D, in some instances leading to nowhere, because we think, hey, we'll build it and we'll start selling boxes to everybody and all will be good in the world, instead of trying to really understand what are we solving for, how do we do it in a way that actually connects with what users really need, and how we do it in a way that while we create all this value for our customers, we also capture enough of it so that we could continue to reinvest. And today, in that regard, our industry is not healthy.